The order of an X-intercept is a very useful characteristic that can be used to help understand the graph of a given polynomial. This characteristic is easy to spot, but powerful when it comes to analyzing polynomials. Now, it's easiest to identify the X-intercepts of any given polynomial when that polynomial is in factored form. If we know the X-intercepts, it's easy to classify their order. Let's look at a first-order X-intercept first. So here's an example of a factored quadratic with two X-intercepts, one at -2 and one at 3. We can say both of these X-intercepts are of order 1. The most obvious way you can tell is the imaginary 1 in the exponent on each component of the factored expression. Now, if I graph this function, you can see that the function passes through the x-axis once at each of these intercepts. That's a key characteristic of X-intercepts of order 1. Remember, when we're talking about the order, we're talking about the behavior of the function at the X-intercepts. So at the X-intercepts, this function passes through the x-axis. Now, if I show you an example of a polynomial with an X-intercept of order 2, you'll likely be able to spot the difference between it and the example of order 1 right away. This exponent indicates that I have an X-intercept of order 2 at x equals 3. You can think of this as two X-intercepts at 3 on top of each other. Graphically, this makes my function behave in such a way that the function simply touches the x-axis at the x-intercept instead of passing directly through the x-axis, as it did in the case of an order 1 x-intercept. So we say an order 2 x-intercept touches the x-axis at the x-intercept as opposed to passing through the x-axis. Now, if you've studied the vertex form of a quadratic before, you've probably seen X-intercepts of order 2. You learn that, for example, the parabola formed by this equation has its vertex at 2, 0, which is right here. Notice that the vertex is touching the x-axis at 2, not passing through. Looking at order 3, you can likely predict what you'll see when we look at an equation of a polynomial with an X-intercept of order 3. An exponent of 3 indicates an X-intercept of order 3. Graphically, this looks like the function is just sitting on the x-axis. Connect this to what you know about cubics. They sort of twist in the middle where they cross the x-axis. So now you know how to use the order of an x-intercept to predict what the graph will look like at the x-intercept in question. Crosses, touches, sits on.